Good morning. This is K. Sai Kirti. So I'm gonna explain about diffie-Hellman key exchange algorithm. So I'll be explaining the introduction first. So it is widely known as key exchange algorithm or key agreement algorithm, developed by Whitefield Diffie and Martin Hellman in 1976. The Diffie-Hellman algorithm is a key exchange protocol that enables two parties communicating over public channel to establish a mutual secret without it being transmitted over the internet. So it enables the two parties who want to communicate with each other to agree on a symmetric key, a key that can be used for encryption and decryption. This algorithm is based on mathematical principles. So the DH enables the two to use a public key to encrypt and decrypt their conversation or data using symmetric cryptography. So this is a clear diagram of the generation that occurs in this process. So this algorithm is based on elliptic curve cryptography, a method of doing public key cryptography based on the algebra structure of elliptic curves over finite fields. The DH also uses the trapdoor function just like many other ways to do public key cryptography. The simple idea of understanding to do the DH algorithm is the following. Now I'm going to explain. The first party picks two prime numbers and tells them to the second party. The second party then picks a secret number and then it computes mod p and sends the result back to the first party. Let's call the result A. Keep in mind that the secret number is not sent to anyone, only the result is. So the step number 3 is then the first party does the same. It selects a secret number B and calculates the result similar to step 2. Then result is sent to the second party. So the second party takes the received number B and calculates the B to the power A mod P. So this is where it gets interesting. The answer in step 5 is same as the answer in step 4. This means both parties will get the same answer no matter the order of exponentiation. So the number we came within step 4 and 5 will be taken as the shared secret key. This key can be used to do any encryption of data that will be transmitted, such as AES, etc. So next is the 5 steps. Like the first, we have to select a prime number Q and then alpha, which is a primitive root of Q. A should be less than Q. Then key generation for user A. Private key x to the power A. Here x to the power A should be less than Q. Now calculation of public key y to the ya is equals to a to the power of xa mod Q. Key generation of user B. Select a private key xb. Here xb should always be less than Q. And now calculation of public key yb is equals to a to the power of xb mod Q. Now calculation of secret key by A, key is equals to y to the power yb to the power of xa mod Q. Calculation of secret key by user B, ya to the power of xb mod Q. So this is how actual algorithm works. So I'm going to show a simple example here. So let us consider like Q is equals to 7 and alpha is equals to 17. And as we know that in the step 2, we have to select XA and it should be less than Q. So like 17, now calculate it in the formula. Phi YA is equals to alpha to the power XA mod Q. So alpha is 17. So 17 to the power 6 mod 7 is equals to 1. So that means YA should be is equal to 1. So the step number 3, we have to calculate YB is equals to alpha to the power of XB mod Q. So XB, as we always know, that is 4. Where XB should be less than Q. So YB is equals to 17. Like alpha is equals to 17. 17 to the power 4 mod 7. If we calculate, the answer is 4. So YB is equals to 4. So the fourth step is k is equals to yb to the power of xa mod q. So yb, as we calculated, it's 4, and xa is 6 mod 7. After calculation, it is 1. So k is equals to 1. So step number 5, k is equals to ya to the power xb mod q. So ya is 1, as we know, and xb is 4. So q is 7. 1 to the power of 4 mod 7 is equals to 1. So as we know, in this particular algorithm, same key is generated on both sides. So k is equals to, we can like choose yb to the power of xa mod q. Here we know that yb is equals to alpha x power b mod q to the power of xa mod q. So we know alpha x power b mod q is alpha xb, and as usual the repeated step xa mod q. So alpha x power b we can write as alpha x power a, and alpha x power a mod q to the power alpha xb mod q. So it is equal to ya to the power of xb mod q. So it is equal to k. So this is the actual procedure of finding Diffie-Hellman key challenge. So I'll be telling the uses of this particular algorithm. So aside from using the algorithm from generating public keys, there are some other places where DH algorithm can be actually used. So the Diffie-Hellman key exchange algorithm can be used to encrypt. One of the first schemes to do is LGAML encryption. One modern example of it is called integrated encryption scheme, which provides security against chosen plain text and chosen clipboard attacks. So next is the password authenticated agreement. So here, when two parties actually share a password authenticated key agreement can be used to prevent the man in the middle attack. This key agreement can be in the form of Diffie-Hellman secure remote password protocol. Is a good example that is based on this technique. So the next one is forward secrecy. Forward secrecy based protocols can generate new key pairs for each new session, and they can automatically discard them when the session is finished. In these forward secrecy protocols, more often than not, the Diffie-Hellman key exchange is used. So the next one, what are the advantages of Diffie-Hellman algorithm? So the sender and receiver don't need any prior knowledge of each other. Once the keys are exchanged, the communication of data can be done through an insecure channel. The sharing of the secret key is safe. So what are the disadvantages of this algorithm? So this algorithm cannot be used for any asymmetric key exchange. It is only for symmetric key exchange. Similarly, it is not used for signing digital signatures, since it doesn't authenticate any party in the transmission. The Diffie-Hellman key exchange is susceptible to a man in the middle attack. So the final conclusion I wanna due to this Diffie-Hellman key exchange, like it has proved to be a useful key exchange system due to its advantages. While it is really tough for someone snooping the network to decrypt the data and get the keys, it is still possible if the numbers generated are not entirely random. Also, the key exchange system makes it possible to do a man in the middle attack. To avoid it, both parties should be very careful at the beginning of the exchange. Thank you.